So, my name is Selena Deckelman, and I created this talk audaciously titled How to Think About Performance. I'm the PostgreSQL user group liaison. I help start user groups for Postgres across the world. And I work for a company called Endpoint Corporation where I do Postgres consulting. So this topic is a little bit broad for 25 minutes. So I'm going to focus in on something real specific that I've been working on in Portland with some other people in my local user group. So I'm just going to give you this case study basically and describe some of the work that we've been doing for the past year that's related to performance. We entitled it the PostgreSQL Portland Performance Practice Project so that we could call it, P5. So we have a regular user group meeting, and then we also have this other one. We meet at Portland State University to talk about performance every month. And we actually are lucky enough to have a really cool, supportive university where a professor there really loves open source, uses open source tools in his classroom. And so he sponsored us, and we also invite some of the students that are there to come to this and talk to us about what they're doing. There's this guy, Mark Wong. I may not know who he is, but he's a really cool guy. He used to work for the Open Source Development Lab, which was located around the area of Portland before it was closed down. And he worked on performance there. He would take very large systems and try to scale them with benchmarking tools out there. He actually created a benchmarking tool. He called it a performance testing tool called DBT2. It's freely available. You can download it and try to run it on your own system. If you do try, you might want to talk to Mark. It's a little challenging, but anyway. So, like I said, we have these meetings at Portland State. We have some hardware donated by HP. We have this data center that Command Prompt graciously allowed us to host our stuff in. And we publish our data online. Go to this link. It's a wiki page that we just dump all of the stats that we gather, and we try to organize it in a way that might make some sense. It is pretty Postgres specific. The workload that we are using anyway to generate the statistics are Postgres specific, but it is interesting if you're interested in file system performance. It's one way of looking at file system performance. So anyway, on to the interesting stuff. So what are we trying to teach people that come to these meetings every month? And I kind of distilled it down to these three things: bottlenecks, base planning, and constraints. So looking at bottlenecks. These are the tools that we use to gather data. We keep all of the raw data, so that ends up being a lot of disk space. We were shipping it off to SourceForge, but they stopped letting us host it there. So now we just find different places to stuff it. But anyway, for the most part, we're only analyzing output from MPStat and IOStat at this time. We could use some help with that. So if you're into this type of thing and you want to look at some raw numbers, come talk to me. But anyway, we post as much as we can online and generate graphs. One thing when we were talking about performance in general is that we'll see people post things that they call benchmarks or things that they call performance tests online, but they don't really talk about what the baseline is. And we think that's a problem. So in everything that we're posting, we're trying to be very clear that our performance tests are application specific. They're pretty focused on Postgres, which has a certain type of usage model. We have really analyzed the file system performance. So before we do anything else, we take FIO and we try to punish these file systems in a way that sometimes makes them crash. And that's very interesting to us because we've found some bugs and been able to give that feedback to kernel developers. Anyway, that's been very good. We also start from the defaults, which a lot of people have a problem with. They're like, well, if you just tune this one parameter, you're going to get way better performance, on XYZ. And that's great, but the fact of the matter is a lot of people, they download an operating system, some Linux distribution, they install it, and they try to run it, right? They don't know anything about what they're supposed to tune. So one of the things that we've tried to do is start from the defaults and then systematically, like I say at the bottom, use science, change, and also change one thing at a time. Try to document that process. So for people that are just learning about how to tune a system, they can follow our thought process and see the incremental improvements as you change one thing at a time. So that, So here's an example of some of the graphs, and I apologize that the scale is not the same on all these. We're still kind of working out exactly what graphing system we're ultimately going to use. But anyway, so this illustrates to me very clearly how our approach might be different than other people who publish performance tests. So first of all, we started out just with RAID 0, which, okay, probably you're not going to be running your database with RAID 0, but maybe you are, I don't know. Anyway, we started out with these tests just with a single disk, which obviously that's not striped, but then we added 2 disks, 3 disks, 4 disks, and compared the differences. So one thing that very much surprised me is you'll see that our ext2, the sequential write performance on this is quite incredible compared to the other 3 lists. And I mean, we don't actually know why. We took these graphs to the Linux Plumbers Conference last year, and we didn't really get a definitive answer there. But anyway, it was just very interesting that difference exists. Another thing that we found that was very interesting was, so you take just a single disk and then you add another disk on ext3, and you actually see a performance regression with the sequential writes. You know, obviously there's probably some margin of error there or whatever, but we just didn't expect that. So one of the things that we do when we present this data, so there's a longer talk that I give where I actually go through all of the different graphs that we produce and try to explain some of the differences and some of the things that we found. But anyway, one of the things that we try to do is challenge conventional wisdom about what file systems actually do when you test them. And it's very important that you don't make any assumptions about, you know, which file system, you know, what a file system is going to do, and also that you actually test the file system that you choose with the application that you're going to use. So anyway, our tests over and over again have verified that, you know, depending on what hardware you have, what file system you're using, you may get very different performance. So anyway, all of these graphs, we have a series of graphs that like this for all the tests that we ran, and you can view them online. Another thing that this is just another example of a test that we ran. There's some other people that have run similar tests with the read-ahead buffer on a file system, but anyway, I'm not going to go into this because it's a little bit complicated. But it's really cool if you set your read-ahead buffer like to about 8 megabytes, you see a pretty dramatic performance improvement, and we've done a bunch of tests to confirm it without any like CPU utilization problems. So a third thing that we talk about with people who come to these meetings are constraints. So you have to keep in mind your constraints whenever you're doing performance testing, and some of those are hardware. We are using HP hardware. We don't have this like huge lab of really cool machines or anything. Just got one, or actually we have 2 now. And so that's what we're running all of our tests on. Operating system is a constraint. We're using Gen 2. And that was because I think a lot of the tools that we wanted to use, we were able to install by default. Time and money, patience, all issues. So anyway, like I said before, this project, we do need people's help. We would like people to look at our data, and we'd like you to look at our data. We'd like you to tell us, you know, if there's a better way that we could be doing it. We invited some anthropologists actually that do a lot of work with Postgres to our meetings, and they started talking to us about error bars and how we should be publishing a little more information about how many times we're running your tests, you know, and that type of thing. So we're working with them now to publish some of that information. And also, the couple different places where I've talked about this project, you know, people have actually taken our code and run these tests on their own systems. We would love to see more of that happen because I think it's a very educational process, and then the information coming out of it about file system performance on, you know, on different types of hardware, it's really useful to everyone. I've actually taken some of these tests and run them on EC2, everybody's all excited about cloud stuff. So hopefully in the next couple of weeks, I'll be publishing some information about that too. So I didn't have, so anyway, so one other thing, since I am coming from Postgres, I thought that I would talk a little bit about some cool stuff that shows how the people that I know in my project, and I'm sure MySQL, like every database project, I'm sure tries to come up with creative ways to improve their performance. But I just thought I'd share some of this, some recent features that I think are cool. One thing that's fairly recent in version 8.3 is this thing called synchronized scan. So if you have a sequential scan that's currently executing, the way that Postgres now works, because this guy Jeff Davis implemented this feature, if another sequential scan that's looking at the same information comes along, it'll just piggyback on that existing one. It won't start at the beginning of the table. It'll just go there and then wrap around. It's a really neat idea. And it's funny that nobody really thought to do that before, right? Like, because you're doing a sequential scan, you got to go through the entire table anyway.
That method was
Oh, really? I didn't know that. I'm sorry. I don't know. Is it implemented in any other databases? And what is the other one? X100. Yeah, so I don't actually think that Jeff knew that. I don't know. I'll ask him. Jeff, he'll be coming here. That's really cool. Yeah, I didn't know that. So anyway, learn something new every day. But so anyway, I just think that's a neat performance feature. Another thing that Postgres does, and I'm not saying that no one else does this. We have this thing called a heap-only tuple, and so one problem that you can have with Postgres is that your indexes get bloated, and that would kind of suck. So if you have an update on a table that actually doesn't impact the index, we now don't try to update the index and add stuff to it that will bloat it. So just that idea of not doing something that you don't have to. I mean that idea applies to a lot of other areas in performance tuning, but it's neat to have it, work out inside the database. Another thing that is very recent, this is an 8.4 feature. Another don't do something you don't have to. So vacuuming, if you're familiar with Postgres, a lot of people hate it. It's annoying. We have this thing called auto vacuum now that will help maintain. So vacuum is a maintenance routine. And so anyway, we have this thing called auto vacuum that will go through and run the maintenance routine for you. But still, when you vacuum, you're essentially doing a sequential scan through all of your tables. So this new feature, this visibility map, it tries to give vacuum hints about things that it can just skip over. So that's less I/O, and hopefully will be a pretty significant performance improvement for Postgres with 8.4, which is in beta. You can download it, try it out. Hopefully we'll have that released fairly soon. So that was it. I don't know. I guess I should have started by saying, if you have questions, you can ask questions. Does anybody have any questions? Yes?
When you're talking about the right cache,
No, I'm sorry, that was a read-ahead buffer, a little bit different.
Do you also map that against to simultaneous writes?
Well, the read-ahead buffer would really mostly affect reads, so no. Yeah. Any other questions? So, how many people in here publish what they would call benchmarks? Anybody in here? Do you post stuff on here? Yeah. And so, what kind of tools do you use for that? Can you just quickly, since I have time? IOZone. Ganglia. Yeah. Sysbench. Okay, what were you saying?
There are own benchmarks, which kind of synthetic thing that cars our system.
And is it open source? Is it something that someone could use?
No.
No.
commercial products. We're only
Okay.
covering about how fast it performs. So
Oh, okay, for a specific commercial product, yeah, okay. How about over here, I saw some hands.
For every task, it's quite complex method to record. You don't use any source.
Uh-huh,
Everything is built to be sure that all the cases are. So we don't measure, we don't know what the instrument is right every time we write the US or.
so that sounds almost like more like a test suite that measures performance. Maybe? No? No, you got a specific tool, okay, sorry. Anyone else? So the tools that we're using, we're just using FIO, and then we use the DBT2 test suite. One thing that I would like to see is a more general approach to the tools that people are using, or at least like standard terminology between the different tools that are out there that do just basic things like what FIO does. But anyway, you get hand back there, go ahead.
Yes, I'm wondering, what are the reasons that make you
Because Mark wrote it.
there are 5 different benchmarks.
Yeah, DBT2 is the only one that's fully implemented, to be honest.
That's one. You need to see something like that every day.
Yeah.
And you have interest in something payment.
I don't know. I guess I would talk to Mark about that.
DBT5 is also running about that every day.
Is that? But is it published? Is that freely available to download that
You can download that.
from SourceForge?
And DBT1 is supposed to have that.
Yeah. My understanding about DBT3 is that it's not very. It's not easier. It's not very good. Okay. Cool. All right. Anything else?